So, hello everyone. Today we are going to learn the USART communication. So, this is nothing but for the asynchronization and synchronization communication between the different Arduinos, or you can do that communication itself with the single Arduino. So, this we will be using Arduino Nano IoT 33, and the other thing that we need to do is create our own library instead of using the simpler serial one. So let's look into that. First, creating the particular library for the serial communication, and basically using there are different types of serial communication. We would be focusing on the USART. So let's look into that. Creating a library, define the name, and then using the particular libraries like Arduino, and for the basic registry programming for the in order to program the register directly, the SAM.h library for the CMSIS. And then it says like we have defined a particular length of the message, so that would be 500 characters. And then the class is like serial communication and the pins for that. And again, we have the serial communication. Now we are setting like what kind of index we are working with. So it will be serial com 0, 1, 2 up to 6. So it's like 0, 1, 2, 3, 4, 5, which means like 6 in total of 6 indexes. And then we have transmitter pin and the receiver pin. Then the board. We are selecting the board. So whatever the user defines, either they want a board 9600 or something different, depending on whatever they like. So reading that, whatever the user gives onto the serial monitor. Then the data bits and the partial bits and stop bits. Again, the maximum we would be dealing with is just 500 characters. Then here we would be using polling because we want to keep on checking instead of having any sort of delay when interrupt happens and having a debounce value. We would just be using polling for this case. Like a person end up writing something onto the serial monitor, and then we could just immediately like if the delay is pretty small, we can immediately act upon it. And then we have the private variable, so what kind of indexes we have selected, whether it's a serial com 0, 1, 2, 3, or all sort of thing. Then the board, there again the all these are defined here, and what kind of helper functions that we need. So enabling the peripherals, and the particular peripheral that we would be dealing with is actually the serial communication one. Earlier, we used to enable all the peripheral at once, but we would be focusing on a particular one. Then the general clock cycle to the serial com, configuring all the pins using the mux and the board, and then configuring for pins for the serial com. And let's move on to the .cpp file. So we have imported our library wiring and strings and mathematical calculation. Again, defining all those. So all those pins are defined. Board is selected to be 0 at the very beginning, and whatever the user selects whenever they go to the serial monitor would be the one that our serial our circuit reads from. And in order to make this circuit, I would be using one Arduino Nano IoT 33, and the RX pin would be directly connected to the transmitter pin. A person could work with multiple Arduino Nano. Minimum would be two for that case, and then they could communicate between two devices. But just for this task, I just have one Arduino Nano IoT 33, so I just communicated it all together with a single and displayed it. And then we have the bool, so it just defines all those things. And at the very beginning, again, here enabling that, and what particular thing that we are enabling is the zero communication. Then we would be using the general clock cycle 0, which is 48 megahertz. Then the pins is TX, which is transmitter, and RX, which is the receiver pins, enabling the actual serial communication and checking the synchronization. Then this part is optional if we wanted to know the state and reset it. So it's pretty good if we reset it earlier on, because sometimes it skips the garbage value we don't want it. And then at the very beginning again, we are selecting what kind of mode. So in this case, the USART would be selecting the asynchronization and using the internal clock and selecting the particular register and then the sampling rate of it. Then we have to clear the bits again. The character size would be 8 bits, and here again, if something goes wrong, then the character size is 0. So the thing that happens in here is like what kind of ports that we are matching to. Either those are enabled or disabled, high or low. All those things would be printed, and I'll be showing you the circuit and showing you the serial monitor what it prints. And again, we are enabling the RX and TX because those are the two pins that are communicating with one another in order to showcase the serial communication using the USRT. And again, checking the synchronization of it. Then printing all those things, polling, keeps on checking it again and again whether there is something written by the user onto the this bar. Currently, I am not connected my Arduino, so when the bar displays whether the user has entered something or not, so it reads that, and then reading from the USRT and then giving it back to us using the serial monitor. And those are good cases. So enabling all the serial communication, as you can see, it enables them. Again, this clock, all these clock cycles takes the general clock of all those serial communication, and again checks like um, checks the synchronization. And again we have set the particular pin, so it actually maps like actually digital board has like pin 18 would be connected to port A or port B depending on the type of board one is using, and the other thing is like whether it's enabled or disabled. So all those things are done here, and computing them and returning the values. So the menu would be like this. Actually, tells the pins that we are connecting. These are the digital pins. Or you can just say these are much more um, like you on the board itself. You could see the TX and RX value over there in case of Arduino Nano, and then a menu is displayed to us like select the option. So if you type enter A, it displays the port A and B and how the GPR pin are actually connected to digital pin or the physical pin of the board. So let's look into the circuit and let's do that. So let's look into this circuit. We have a transmitter and the receiver. So these are connected to one another to do the USART communication. Let's run the code, reset it, the Arduino Nano IoT33, and it actually tells us like if we want to display the connections of port A and port B with the GPIO pin. So let's look into that. If I select the option A, it should print me something like, so 14 pin is connected to 0A2 port and 6 is connected to 04 and so on. So it prints the A port and same happens with the port number B. Although the pins are 32 pins in either the port A and the port B, but what happens is it depends on the what kind of microcontroller we are using. So this is the Arduino Nano IoT33. The mapping of the MCU depends on what kind of models you use. Even though the SMD21 has like 64 pins, but all those physical pins are not actually mapped to all the peripherals of the board itself. So that's why we get these numbers and the total doesn't add up to 64. So that's how you do it. Thanks for watching the video.